Okay, so for this one, you're allowed to take what's inside of a radical and break it up into two separate, if those things are being multiplied. So if they're being multiplied, you can definitely do that. In this case, sometimes it's advantageous. Again, the roots have to be the same. So like if it's third root, it has to be third root and third root here. But sometimes it's advantageous to start here and kind of group them together. So in this one, I'm going to go ahead and group those together. So kind of use the property backwards. I'd say -4 times 2 is -8, because that actually makes the problem easier because the cube root of -8, you probably know, is -2. If you don't know that, you could do the prime factorization of 8, which is 2 to the third power. The answer is negative because it's a cube root of a negative. So 2 to the third is, the third root of that is 2. Again, here, I'm just going to go ahead and put these together because I think it might make the problem easier. So 8 times 3 is 24. X to the fifth times x to the first is x to the sixth. And this might be a little easier to solve this way. Let's see, it's still got a prime factorization there. So again, you could always use your calculator to do some prime factorization for you. So factor 24 to the third times 3. So we have, really, if you want to write that out just so you can see it, so we have the square root of 2 to the third times the square root of 3 times, I'm going to write this like we learned the other day in rational exponent form. So this is really a 2 right there when it says square root. So this is 6 over 2. So this is going to be 2 simplifies nicely, the cube root of 2. I'm sorry, that's not a square root. That's a square root, not a cube root. So actually, just when it's a square root, you're looking for 2 of those. So a 2 does come out, but what's left over inside is going to be a 2 and a 3 in that case. So let me just kind of, sorry. Okay, so we have 2, and then left over inside there's 2 times 3, which is 6. X to the third is also simplified there on the outside of that. So be 2x to the third times the square root of 6, because there was 2 of these that come out. If you look at that, that's really the square root of 2 squared times the square root of 2 to the first. So this one simplifies, this one doesn't. So it's left over inside there. So square root of 2 times square root of 3 is square root of 6 there. Okay, let's look at these. So cube root of 4. I really can't combine these at all, right? So this is really something that can't really be simplified. In fact, I'd just probably leave the answer like that because this is the second root and this is the third root there. So those don't combine nicely. I would not try to do that. This one, let's just see what happens here. So I'm going to multiply the 3 times 2 on the outside. So that's 6 times the cube root of, let's simplify inside. So 5 times 50 is 250. Y to the third times y to the fourth is y to the seventh. So with 250, let's see what the prime factorization is. So menu 2, 3, 250. 2 times 5 to the third. So this is 6. I'm just going to write it like this, times cube root of 2 times cube root of 5 to the third. Again, I really like to use the rational exponents when it's a variable like this. So 7 over 3. It's one way of doing it. So let's see what that equals. So this would be 6 times cube root of 2 is just that. It's cube root of 2. This one simplifies nicely. It's going to be times 5 here. And then if you think about this, like that's really, if you think about this, this is y to the, y to the power of 2 and 1/3, if that makes sense. So some of that's going to simplify the 2 and 1/3. So we have, or if you think about it this way, you could write this as the cube root of y to the third times, I'm just thinking different ways, the cube root of y to the third times the cube root of y to the first. You really got, those two y's are going to come out really nicely, just those two y's are, there's a y left over inside. So y squared comes out, there's a y left over inside. So your final answer would be 30y squared times the cube root of 2y. Quotient property is very similar. So you're allowed to, if you have the square root or some root of a fraction, you could break it up into two separate fractions. Usually that's helpful. Although part A here, you see both of those are not in radical form, so I really can't break that one up because I don't have a fraction. I don't have a square root divided by a square root, so I can't use the property here. But I might be able to simplify the numerator. If you don't know the prime factorization of 8, it is 2 to the third, right? So I think there's a pair of 2's with a 2 left over there. So this, and the numerator would be 2 root 2, and x to the, what fraction? This would be 4 over 2 power over 2x squared, which is actually 2x squared, square root of 2, over 2x squared, and you can see those cancel, so you get square root of 2 over 1, or square root of 2. Okay, let's see if we can actually use the property here. So I think we can. So this is going to make this problem easier. So I'm going to write this as one big fraction. So this is going to be 50 over 2, and then x to the 7th over x to the third. And I'm going to simplify that if I can. So 50 over 2 is 25. X to the 7th over x to the fourth. The third is x to the fourth. Well, now this is a much easier problem. You probably know the answer. Square root of 25 is 5. If you don't know, square root of x to the fourth would be 4 over 2 power, which is 5x squared. Simplify, use factor trees, or factor in your calculator. So menu 2398 and menu 2324. This one is 2 times 7 squared, right? So this would be, so the 7 squared, the 7 is going to come out because I'm looking for 2 of anything here. But underneath the radical, we still have a 2. I have 3 x's, I only need 2 of them. So one x is going to come out. That one simplifies, the x squared part is, but there's an x left over. So I think my answer would be, I don't know why I put such a big space there, but would be that. This one, 24, is 2 cubed times 3. So this time I am looking for the cube root of this one. So it would be 2 cubed times the cube root of 3. Yeah. And then another way of thinking about this is, so cube root of x to the third times cube root of x to the first. And if I break up the y term, cube root of y to the third times cube root of y to the second. So I'm looking for groups of 3 of anything. So you see some of these, like this one simplifies nicely, this one simplifies nicely, this one simplifies nicely. The other ones, not so much. They'll be left over in the radical. So what comes out is this is really 2, this one's really x, this one's really y. What's left over in the cube root is a 3, an x, and a y squared. I need 3 to come out there, and none of those have enough friends or partners there that are similar to work. So do your prime factor tree, or just menu 2, 3, 64, 2 to the 6. So I want to see this little bit of work that you do 2 to the 6. So that's really that would be 5th root of 2 to the 5th times 5th root to the 1st. That's 2 to the 6th. Again, we're breaking up this 7th. We only need 5, so I'm putting 5 of them together, and 2 of them are just kind of going to be left over inside the radical. This one should simplify, this one should simplify. So we get 2x times the 5th root of what's left over inside, 2x squared. It's all one term there. Rationalize the denominator. So the denominator needs to be a rational number. So square root of 2 is not rational. So this one's pretty easy. Just multiply by square root of 2 over square root of 2. which is really like multiplying by 1. So it doesn't change the value of this, but it does change the form. Square root of 2 times square root of 2 is square root of 4, or 2. So my answer now, the denominator has been rationalized. There's no irrational number in the denominator. 2 is nice and rational. Square root of 2 is irrational, but now it's in the numerator, which is somehow okay. With square roots, it's pretty easy. I mean, just, you don't have to think about it too much. Cube roots, you've got to think about it. We've got to multiply by something here. But think about the end in mind before I think about what we're going to actually multiply by. I really ideally want cube root of x to the what power here? What would be ideal? We want to simplify it. My goal is to get third power there, because that's just going to be x if I simplify. Ah, that's nice and rational. Well, I have x to the first. I want x to the third inside of there, so I need to multiply by cube root of x to the second. So both top and bottom, you're going to multiply by cube root of x to the second. So you get 2 times cube root of x squared, 2 times cube root of x squared, all over x. Same thing here with fourth root. You got to think about this. So before we actually write what we're going to multiply by, we're going to think about the end, begin with the end in mind. I really want fourth root of 2 to the what fraction, what power there. I want 2 to the fourth ideally, because that would just be 2, which is nice and rational. So I'm to the first power, I need fourth power, so I'm going to multiply by fourth root of 2 to the third, fourth root of 2 to the third, fourth root of 2 to the third. And you can write that different ways. You can write fourth of 8, because 2 to the third is 8, and that would be fine to write. This one, again, we need to think about the end in mind here. So what do we need to multiply by? The end, I need to get cube root of 3 to the third. Ideally, that's what I want, because the denominator would just be 3. So that's to the first power. I really need 2 of those, so 3 squared. And those should multiply nicely. So cube root, using our property we just learned. So 5 times 9 is 45. So cube root of 45 divided by 3 would be the way to go there. That's it. That's your lesson for today.